This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's go over some proofs involving triangles. Here's our first example. FH is perpendicular to GH. Complete the proof that the measure of angle F plus the measure of angle G is equal to 90 degrees. This is a two-column proof, where the statements go on the left and the reason each statement is true goes on the right. This time, we'll just fill in the reasons. The first statement in our proof says, FH is perpendicular to GH, which is given in the problem statement, so we'll put given as the reason for this statement. Usually a proof will start off with something that is already given in the problem statement or diagram. The next statement says that the measure of angle H is equal to 90 degrees. This is exactly what it means for FH and GH to be perpendicular, so our reason is the definition of perpendicular lines. Now, the measure of angle F plus the measure of angle G plus the measure of angle H is equal to 180 degrees. Why is that true? If you remember, the sum of the three angles in any triangle is 180 degrees, which is called the Triangle Angle Sum Theorem. Okay, our next statement uses the equation from this line, but since we also showed that angle H is equal to 90 degrees, we can replace the measure of angle H with 90 degrees. So the reason for this statement is substitution. Now, if we subtract 90 degrees from each side, we get this equation. The measure of angle F plus the measure of angle G is equal to 90 degrees. We'll put the properties of addition, subtraction, multiplication, and division as the reason for that statement. Great! We proved that the two acute angles in this right triangle sum to 90 degrees. All right, our second example says GI is parallel to FJ. Complete the proof that the measure of angle F plus the measure of angle J is equal to the measure of angle HGJ without using the Triangle Angle Sum Theorem. Our first statement is GI is parallel to FJ, which is given in the problem statement. Notice that our next two statements are about congruent angles, but how will we find these? We'll use the fact that we have two parallel lines cut by a transversal, since we know a lot about angles formed this way. So let's see, we want to show angle J is congruent to angle IGJ. These are alternate interior angles, so we know that they are congruent by the alternate interior angles theorem. For our next set of angles, we'll look at a different transversal. Angle F is here and angle HGI is here. These are corresponding angles, so they are congruent by the corresponding angles theorem. The next statement says that the measure of angle HGI plus the measure of angle IGJ equals the measure of angle HGJ. Well, looking at our diagram, we see that angle HGI and IGJ together form angle HGJ. So we know this statement is true because of the additive property of angle measure. We're down to our final statement, but where did this come from? Let's look at that same equation from the previous line. We've shown that angle HGI and angle F are congruent, so we substituted the measure of angle F for the measure of angle HGI in our final statement. Similarly, we know that angle J and angle IGJ are congruent, so we substituted in the measure of angle J for the measure of angle IGJ. So the reason for this final statement is substitution. Great! We showed that the exterior angle in this triangle is equal to the sum of the two interior angles opposite from it, and we didn't use the Triangle Angle Sum Theorem. All right, here's our last example. UY is parallel to VX. Complete the proof that the measure of angle U plus the measure of angle Y plus the measure of angle UVY equals 180 degrees without using the Triangle Angle Sum Theorem. All right, first, UY is parallel to VX is given in the problem statement. Similar to our last example, these parallel lines are cut by transversals, so several pairs of congruent angles are formed here. Looking at the transversal UW, angle U is congruent to angle WVX because they are corresponding angles. And when we look at transversal YV, we see that angle y is congruent to angle xvy because they are alternate interior angles. Now, like in our last proof, we can say that the measure of angle wvy is equal to the measure of angle wvx plus the measure of angle xvy by the additive property of angle measure. Next, we'll take this same equation but substitute angle u for angle wvx and angle y for xvy. So our equation reads, the measure of angle wvy is equal to the measure of angle u plus the measure of angle y. And we got that equation by substitution. Okay, we're almost there. We need to figure out the next statement. Somewhere in the proof, we'll need to incorporate 180 degrees, since that's part of what we're trying to prove. We can say that the measure of angle uvy plus the measure of angle wvy is equal to 180 degrees, because they form a linear pair. Great! Now we just need to make our final statement, which should be what we're trying to prove. The measure of angle uvy plus the measure of angle u plus the measure of angle y equals 180 degrees. How do we know this? Well, we already showed that the measure of angle wvy is equal to the measure of angle u plus the measure of angle y. So we'll substitute that in for angle wvy to get this equation. That was a tough one, but we did it. We proved that the three interior angles of a triangle sum to 180 degrees. Great work on these problems. You're ready to try a few on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.